Welcome to Biotosis everybody. We are starting with the lecture series now, and the first subject is printing techniques, and we'll cover unit 1 today. So what is printing techniques? So it is also called additive manufacturing technology, commonly known as 3D printing. So printing techniques ka basic is 3D printing, and it's a process of creating objects by adding material in a layer by layer fashion. How do we do that is it is nothing but printing only. How do we do 2D printing? That is just one more dimension is added to it. So if we talk in terms of common man, how do we put henna in our hands, right? Like how do we put mehndi? It is like the ink, and we just print it on our hands. So although the henna gives color in the hand and we have to remove the drawing part of it or it gets shed off, but then 3D printing is nothing but like that only. You have to imagine it like that only, and like we are putting henna, that is the only way. Like if you are putting one slice of henna, suppose you put one square and then you put another square on top of it with henna, that is 3D printing. Like that is called layer by layer, based on layer by layer. And what are the digital models? We'll talk about it later, but I thought this is the very basic idea of it. Okay, so what is the difference from traditional manufacturing? So in additive manufacturing, we have more flexibility of design. We can make our models. If you know what are CAD models, you would know that we can give anything and everything into the computer. Like we make shapes, we all those who have used paint in class prep first, right? In computer classes we were taught paint. So how we used to make shapes in paint. CAD models or CAD softwares are somewhat like that only. They are not very difficult to learn nowadays. Tinkercad is one of the most easy versions and free versions where you can play around and learn about it. So that is there. So it is like paint only. The functionality is more or less like paint software only. Now relevance we all know, but we'll talk about it, which is used across industries including healthcare, aerospace. So now we are talking about building bridges with 3D bioprinting, building all sorts of plastic things, all sorts of since we are a biotechnology channel, we'll be more focused upon how it is used in biotechnology and healthcare and biomedical industries. But people have used 3D bioprinting already in various other arenas. So this was the introduction. Let's move on, and now we will learn about prototyping the fundamentals. So what is that? It refers to creating preliminary models of product to evaluate its design, functionality and manufacturability. It is nothing but designing a prototype. Have you seen those Discovery channels where they showed that before making the cars, they designed a prototype on the computer, right? Before making the architects, before they make anything on ground, they create first drawings of it, and then they make, like with different things like different household things and smaller things, they make models, right? That is only prototyping, which is following. Prototyping also is sometimes same dimension or same ratios mein, whatever. Suppose I want to make a 10 by 10 meter ka, there is a cube that I want to make, right? So prototyping is nothing but designing that 10 by 10 cube on a computer, or otherwise 10 by 10 ka cube, but then we have to make it in meters. We will make it in centimeters and try if we are able to create it or not. That is also prototyping. what is the benefit? It is faster product development cycles. Once we know that this dimension is working out, this dimension is solid, once we know that that model is working out, or it is looking good, or it is working, because we are checking it on computers, we are making it, like, that is why we see dimensions are most important when we talk about prototyping. Ability to multiply the iterations. So like once we have created, we can just auto save it and print 50 or 60 models of the same dimension. That is what prototyping is, creating a model and then hitting into 2x or into 3x models of that, right? Which is obviously saving a lot of cost, right? Every time you have to design and print, suppose you are hand drawing something, right? So it is all prototyping. In common world, we can say that it is nothing but carbon copy paper. We write it, and it is the number of carbon papers we keep on 3 pages or 4 pages, same thing is written. This is also one type of prototyping. In common printers also, in 2D printers also, if we have, like, if 10 students of a class want a question paper and it is 1 page long, we just go take scan it once and just ask the printer to make 10 copies of it. It's nothing but that. Okay, moving on. Historical development. So this is something for us to read, which is early beginnings. The concept of the additive manufacturing technology dates back to 1980s with the intervention of stereolithography by Charles Hull in 1986. In 1980s, introduction of stereolithography and fused deposition modeling was done. Okay, in 1990s, emergence of selective laser sintering, which is SLS, and significant advancement in polymer-based 3D printing was done. In 2000s, expansion into the metals and ceramics, leading to broader industrial applications. And then in 2010, widespread adoption of various industries with advancement in materials and technologies. Now, what are the advantages? Which is, we already have talked about it, but let's discuss in terms of what we have to write in exam, which is customization. Complex geometry, customization becomes easy, right? Because we can create 10 models after creating just one. And when you are drawing something, or when you are creating a model on a paint, like, right, or CAD model, you can go as much creative as you want to, and you can try and see whatever works out on the computer itself before it is printed, right? So all the complex geometrics geometrices we can try. Okay, reduced waste. Obviously there is no waste, because earlier what we use, how is this reduced waste is coming out? Earlier, when we have to make something, we take a big box. If you want to make suppose you want to make a iron carving, say you have to make something, so they used to carve, or they used to create get a big sheet of iron and they used to cut it down. So rest of all the waste product was, like, the parts we needed were kept, and the rest of the things, like the katran part of it, the waste part of it, was wasted, right? Now here we are creating something like liquid iron. We are putting into the 3D printer, and only the part we need is being printed. So there is no waste. The rest of the part will be used only when we have to create another piece. Okay, so that is what it is. Quick prototyping is nothing but making it easier for us to make different models and switch from models to models. Suppose we have to create 10 models in a day. Suppose you are working in a toy store. How can a 3D printer help you in that? So suppose you have all your cars all your toys are created of one type of plastic. Mostly all the types of cars are created of one types of plastic, okay? But if you are thinking of future, you don't have to create a lot of stock. You just create a 3D you just buy a 3D printer which uses that particular plastic, or that it's customizable, or which can use any type of plastic, right? Now that plastic is used as ink. Now whoever child or whoever wants a toy, they just picks a model out of a catalog or a book that you show. They say, okay, I want this yellow car which is nano, which looks like a nano car, or somebody wants a car which looks like a Tesla car. You have a code saved in your bioprinter named nano as 1, Tesla as 2. You can just go and select 1 and print a nano car, select 2 and print a Tesla car. You don't have to keep all the stock and wait for anyone to pick one of those. You might have 10 Teslas and 5 nanos, and the demand could be like 5 Teslas and 100 nanos, right? So that is where 3D bioprinting is helping in very common things. And I'm talking about just a plastic toy shop, but then industrial, maybe the use is vast, and actually the places that we are using is aerospace engineering mein. So you have to create aircraft ke parts, right? The material that it is made out of is very costly, right? Plastic is comparatively cheap. Even if we are wasting it, it is affecting the environment, yes, but it is not as costly to the person who is making it, right? But in aerospace engineering or such industries where the cost of materials are higher, this can be a real asset. This printing techniques can anyways be a real asset, but these are the few examples that I wanted to share. Supply chain efficacy, like I said, potential to produce parts, ornament, reducing the need of large inventories, right? Now, what are the commonly used terms in 3D bioprinting? Now that we understand what is 3D bioprinting, how is it working, we should also understand some terminologies of it, right? Because we are studying this subject, so we should know all these things. So layer thickness is nothing but the height of layer, right? When anybody says the layer thickness should be this, what you get out of it is, once you're printing a layer, the dimension of that should be 1 mm, 2 mm, so that all the layers are equal. Or sometimes you need one layer thicker than the other. You have to put commands into the system. So how will you know that what command you have to put? So that is called nothing but layer thickness. It is easy but had to be shared. What is build platform is where this 3D constructed model is kept, right? So build platform is where your model will be placed, right? If we are printing it layer by layer, on the build platform is where it is getting printed, and it will be ready on that platform itself. What is support structures? So temporary structures that support overhanging parts of design during the printing, right? Now, what is infill? Infill is nothing but internal structures of printed object, right? So those are the internal thing. The outer layer is something. How much infill is nothing but suppose you're making a cube. Do you want a hollow cube, or do you want like a thick one, or a full covered cube which is like solid cube, right? Do you want a hollow cube or a solid cube? That is what infill is. You can select percentages or how much infill do you want That is what you can do with it. Okay, now moving on to the process chain in additive manufacturing. So the steps involved are 3D modeling, data conversion and transmission, preparation, building and post processing. Let's read and I'll explain as we go along, right? Creating a digital representation of object using CAD software. We have already talked about CAD software. It's somewhat like Paint, right? We create, and then if suppose you were 3D model can also be like there was a show Shakalaka Boom Boom, right? So there was a pencil, magic pencil, right? So you can just create into the CAD software and 3D printer would bring it up. So I think the person who created 3D printer was a big fan of Shakalaka Boom Boom. Now next, data conversion and transmission. So the models are converted and put into the 3D printer like in a PDF form, right? We cannot just, we can also connect a computer to the printer, but mostly the printers are intelligent enough to not use a computer. Okay, so we just take all the diagrams, all the designs in an STL format into a PDF, and then we plug that PDF into the 3D printer and the software analyzes it and prints it. Now preparation is ensuring the model is properly oriented and supported for printing. Many a times there are things that we want to print that need support, so we also print it in a support bath. So the printing is actually happening in a liquid or a gel like format, gel like solution, where you can do what is, you can just, the printing part is the print has dipped into the gel and it prints. As the printer is printing the material, the gel will get separated, like it will leave its place, and the structure that we want will stay intact, and in the rest of the parts the gel will be there to support it. The gel should be in such a format that it is not as strong that the structure, the printhead is not able to move properly as a way. So all these things we have to make sure that we keep in mind. What gel or what support bath are we talking about? As we move ahead in the subject, we'll understand it better. Okay, now building is actually printing process of the object in again the layer by layer fashion. What is post processing is many a times, or 99.99% of the times, we are printing all the things in an ink format, right? The printer uses ink, but now it is creating solid objects. So sometimes we need some post processing to solidify it more, right? To make it rigid, to make it more firm in terms of whatever use we want to put it to. Many a times it's also final treatments or maybe some or the other things that it needs before it goes into actual use. Now what is 3D modeling actually? 3D modeling is a process of creating a digital representation of object using a specialized software. Like we told earlier only, AutoCAD, SolidWorks, Blender or Tinkercad. Now the importance is accurate 3D modeling are crucial for successful printing as they determine the final shape, structure and quality of the printed project. So modeling is very important because whatever we make, however our model is, that is exactly where how our structure is going to look like, right? So what all we need to take care while modeling? The dimensions, right? The layer thickness is what we have to make sure. While we are creating a model, we also have to keep in mind what ink are we going to use, because sometimes if we say we want 1 mm thickness and our liquid is our ink is very fluid, right? The viscosity of that ink is really very less. So 1 mm will be very difficult for it to hold, right? It will be much less. So those are the things that need to be considered before creating a model, while creating a model. Now, data conversion and transmission. Like I said, it is created in a software, and then it can print in a PDF form or something, like an STL format file is used to put those models into the printer. Now, what other formats also some printers use are 3MF, OBJ, AMF, right? Now, what is transmission? Transmission is nothing but transmitting the converted file into the 3D printer software for slicing and printing. Now, one new term is there, that is slicing. What is slicing? So, slicing software is nothing but commands that is telling printer to start from A point, go to B point, then go to C point and D point, like giving it step by step guide as of how you have to print, because the printer is okay, it's a machine, it doesn't know. You are giving him a solid cube to print, and you have given it a print head which is very like thin, right? Like I told in the beginning, it's like henna cone, it is very like thin. So if we are printing for bridges and everything, it is comparatively thicker, but then again, for those that much thicker print heads or printed nozzles, we have to create much bigger structures, right? So what is happening exactly is, we have to, the slicing software gives the printer directions, dimensions as of start from A, print 2 centimeters, then start from B and go to 45-degree angle, and then print for 5 centimeters, and then go to C at 45-degree angles. This is what slicing software does. Okay. Moving on, checking and preparing. So what is that? Is nothing but model verification, ensuring that a 3D model has no errors such as holes or gaps, and that could affect the print, right? Orientation, proper orientation and the modeling to optimize printing quality, minimize support structures and reduce the printing time. Support generation, which is adding necessary important structures to prevent deformation during printing. Now what is building? We have already discussed it, but now to understand it deeper, layer by layer construction. So we have to build. How do we, when we are talking about building anything, we know that the houses are built. Okay, how our houses are built? The architects creates a model that, okay, this is my model and this is how I want to create your house. Then he starts with, then he starts creating a boundary. Okay, he puts one brick at a time and then cement in between, and he creates a cube, and then he starts filling the brick one over the other, and that is how your room is created, and your home is created eventually. So that is what is happening here also. Now what is what are the material used, right? Like in building houses, we use bricks. Like in plastics, we have to use those polymers and those things, right? So for printing, we can use any type of materials. Most commonly used are polymers, metals, ceramics and composites, depending on what we want to create and how are we using our printer for, what is the purpose of our printing. Now what are the basic printing techniques, which is fused deposition modeling, stereolithography, selective layer sintering and more. We will talk about more techniques moving on. Now post processing. What is post processing? Like I said, it is nothing but giving more strength to the structure that we have created. But let's read what the books say. Support removal, like detaching any support structures added during the printing. Like I said, many a times we print it in a gel or something, right, in a liquid bath or support bath, so we have to detach that, or we any type of attachment is there, we have to detach that. Surface finishing, which is techniques like sanding, polishing, or maybe painting to improve the object's appearance. Or maybe branding. Suppose you are a brand. Now that toy store that we were talking about, the 3D printer has already created the model for you. Now you'll create your like logo on it. Like we have our Biotosis logo on every slide, right? So you will create a logo on it. What is thermal and chemical treatments? That is also for more solidification, like enhancing the mechanical properties or surface quality through heat treatment or chemical processes. Now let's understand what are the files that we are giving to the system. That is RP data formats, which is rapid prototyping data formats. That are STL, AMF, 3MF that we talked about, which is standard tessellation language. AMF is additive manufacturing file, and this is 3MF is 3D manufacturing format, which is nothing but, STL is nothing but used file format that describes the surface geometry of 3D models. XML additive manufacturing is XML based open standard for 3D printing, and 3MF is modern format that includes detailed model information such as color, texture, etc. right? Now classification of additive manufacturing processes. So what is that is material extrusion. It is, now again we go back to henna. The cone, those who have applied henna would relate. Sometimes the henna is very rigid, we have to put more pressure, and sometimes the henna is new, the water is more into it, it flows out easily, right? For boys, when you play Holi, there is this pitchkari, right? So sometimes your pitchkari is old or broken, you have to put more pressure into it to let the color water go out of it. And sometimes it's new, so that is good, you can just put whatever pressure you want to, you feel like, or it's easy, comparatively easy. So, and the pressure for guns, gun pitchkaris are different, and pressure for the old conventional pitchkaris is different, and when you put plastic and steel, these are different. Why am I talking about all these things? Because that matters. What type of print head do we have? Okay, what is the material? What is the nozzle size, which is nozzle diameter, out of which the ink has to flow? And what is the viscosity of the bio ink that we are using, or the ink that we are using, right? So that fused deposition modeling, where material is extruded through the nozzle, right? What is vat photopolymerization? This is using light to solidify a liquid resin layer by layer. Like resin jewelries are there, right? It's in liquid format, then we do some treatment to it, and then this solidify. Sometimes in simple sunlight also they solidify. So depending upon what type of material we are using, we can do that. Powder bed fusion, which is melting or sintering powder particles using a laser or electron beam. What is material jetting? Droplets of material are deposited and cured layer by layer. Binder jetting is a binder is selectively deposited onto a powder bed to bound particles together. Now, last but not the least, the application of 3D bioprinting or printing techniques in various fields, which is healthcare, in creation of custom implants, prosthetics, dental devices, and bioprinting of tissues. In aerospace and automotive industries, in for manufacturing of lightweight complex parts with high precision. Consumer goods में customizable products like jewelries, footwear and household items, etc. Construction में 3D printing of building components and even entire structures using large scale printers. I have already seen 3D printed houses, 3D printed bridges. So we will talk about in our further lectures where you can find it. There are videos on the YouTube also, but if you don't feel like going through them, we will talk about it in our further videos. Now, education and research is rapid prototyping of educational models and experimental research, which is nothing but mostly related to organ printing, right? We are trying to create organs so that we can use less animals and do the testing otherwise, which will be more good. Why? Because animals are only 80% match, but if we are able to create our own organs, those will be better, 99% match, right? And that's it for today, guys. If you have any doubts, please comment below and we'll post up the next lecture soon.